Welcome to this FP2 video on multiplying and dividing complex numbers. So if you recall from FP1 1.6, we had that Z1 times Z2 inside the modulus would be the modulus of Z1 multiplied by the modulus of Z2. We also had something similar with the argument, where the argument of Z1 times Z2 is the argument of Z1 plus the argument of Z2. And then in terms of dividing, we had Z1 over Z2 inside the modulus is the same as the modulus of Z1 divided by the modulus of Z2. And with the argument of Z1 over Z2, we have that's the argument of Z1 minus the argument of Z2. So these results, these come from FP1. I'm not going to go through them, where they come from. You can go back and watch the videos on that. Now, if we apply these results to exponential form, and we're looking at, say, Z1 equals R1 e I to theta 1, and Z2 equals R2 e I to theta 2, then Z1 times Z2 becomes R1 R2 e to the I theta 1 plus theta 2. And similarly, Z1 divided by Z2 becomes R1 over R2 e to the I theta 1 minus theta 2. Okay, now these appear to basically follow the rules of indices. However, you cannot assume that the laws of indices work in the same way with complex numbers as they do with real numbers. Now, this result just shows that they can be applied in these specific cases, but it might not always be the case. Okay, so don't assume anything. Now, this is what the basis of what we're going to be looking at today. It's a very straightforward video on multiplying and dividing. So let's get into the first example. So we want to multiply these two together. So this is going to equal 3 times 5. And then I've got e to the I, and it's pi by 6. Plus pi by 3. And that's going to give me 15e to the pi by 2i. Okay, now converting this into modulus argument form will give me 15 cos pi by 2 plus I sine pi by 2. And cos pi by 2 is 0 and sine pi by 2 is 1. So in the end, I get that this is 15i. So what I've done is I've done a multiplication, and then it's just been a conversion afterwards. Okay, fairly straightforward. Let's have a look at a division. So here is my division, and what I first want to do is convert it into exponential form. So this is 3e to the 5 pi by 12i divided by root 3e to the 3 pi by 4i. Now that is 3 over root 3 e, take the I outside the brackets, and it's 5 pi by 12 minus 3 pi by 4. So 3 over root 3 is just simply root 3 e to the, now 5/12 pi minus 3/4 pi is minus 1/3 pi, so minus pi over 3i. And that there is now written in exponential form and simplified. Okay, so these kind of things now, they're not going to form questions on their own, they're going to become part of questions. So this is really just about learning a skill to help you manipulate your questions that you might have in the future. Now, before we get into the questions, I've got just one more example for you. So we've got this example, gives us some information, use geometrical reasoning to find the two possibilities for W, giving your answer in exponential form. So first we can see that ZW equals 2Z modulus. Now this is the modulus of Z and modulus of W equals 2 times the modulus of Z. So clearly the modulus of W must equal 2. So we can state that straight away. Now if I do a quick sketch of the Z, okay, it's 1 minus 1, so it's down here. So this is alpha, and 1 there. So alpha is arc tan 1 over 1, which is just going to be pi by 4. Therefore, theta, or arg z, is going to be negative pi by 4. So far we've created two key pieces of information. Now, finally, we've got this piece of information here. So this tells us that this must lie on the real axis. So it must lie, either here, so ZW1, or, and I'll do this in a different color, purple I think, it lies here, ZW2. So that is what we know, and we know already that Z is down here being 1 minus I, and this is, our minus quarter pi. So that's all the information that we're given. Now we can go ahead and work out what W must be. Because if this is ZW equals 0, then arg of ZW must equal 0 or pi. Yeah, or this case minus pi. So effectively, if this is Z, W will either take Z this way or take Z this way. Could take Z all the way around this way. So basically we've got that theta minus pi by 4 equals 0 or pi, and that pi could be negative pi. I'll show you if I did it with pi and what it would be if I did it with negative pi. So this means that theta equals pi by 4 or theta equals 5 pi by 4. Now 5 pi by 4 is more than pi. Okay, so generally, because we're looking at values between pi and minus pi, go into the negative pi would probably make sense. So I could take, 2 pi away from this. Or what I could do is do it to the negative pi, because that's this one. and then this becomes minus 3 pi by 4. So these are my two answers. So W1 equals, now what's that? That's 2e to the pi by 4i. And W2 equals 2e to the minus 3 pi by 4i. And that's how we do this type of question. Okay, so it's W would either take the Z this way, which would be this one, or take Z this direction, which would be this one. Okay, it could take this direction to the positive W, which was that 5 over 4 pi, but of course that is outside of the range that we generally use. It's not wrong though. Okay, it's not wrong, but it's outside of the range that we generally use. So there you have 3 examples. And now before we jump into the questions, I just want to remind you to, if you find the video useful, hit the like button, subscribe if you're yet to subscribe, and if you're willing and able to help me out financially, hit that join button. Even if it's only for a month, really helps me out. So 5 questions in this video, quite short and sweet though, fairly easy to do. The last one being like the last example that we looked at. Okay, that's actually a past paper question that I found there. Okay, I think worth about 3 or 4 marks. Anyway, pause the video now. And welcome back. Hopefully you paused, had a go at these questions, didn't have too many problems, but let's look at the solutions. So we got the multiplication one, so we got 5 times 2, e, and then we've got I outside the brackets, and 3/4 pi plus pi by 6. So that's 10e to the power 11 pi by 12i. Nice, easy, nice and quick to get it into that form. But now we need to get it into this form, the x plus I y. So now we need to change this into our modulus argument form. So cos 11 over 12 pi plus I sine 11 over 12 pi. So that is going to be 10 times minus 0.9659 plus 0.2588. These are the four significant figures, and times them by the and this is an I, sorry, and times them by the 10, we get minus 9.66. If we do the 3 significant figures, plus 2.59i to 3 significant figures there. Okay, so that is question 1 complete. Okay, question 2. So we got root 2 over 2, e to the I, and then we've got 5 pi over 7 minus pi over 7. So root 2 over 2 stays as root 2 over 2. E to the I, oh, let's not put the I in yet. That's going to be 4 pi by 7 I. Okay, now converting it. So root 2 over 2 cos 4 pi by 7 plus I sine 4 pi by 7. So root 2 over 2 minus 0.2225. Carrying on that. And not I sine, is 0.9749 and so on. Probably could have picked better fractions to give nicer answers here, but now I'll just write down the final answers, and that works out to be minus 0.157 plus 0.689i, correct to 3 significant figures. So not very nice numbers that I chose. I do apologise, I should have worked these out beforehand to give you some nice values to work with. But it's just the process, you just practice in the process. So hopefully you got these answers out. So for this one, first change it into its exponential form. So this is 5e to the 3 theta I times by e to the 2 theta I there. So this is 5e and we add the powers, so it's 5 theta I. Or you can write 5e to the 5i theta if you want to write it that way round. Okay, but that is just all there is to it. Nice and easy. Let's move on to question 4. Again, we want to first change it into its exponential form. So that's 4e to the pi by 6 and 3e to the pi by 3i. So that's 4 over 3e to the pi by 6 minus pi by 3. So it's 4/3 e to the minus pi by 6i. And that is in the form that we want it. So dead easy, nice and simple. Hopefully you got that one out. Let's move on to the last question. So in this one we're given z. So modulus of z is going to be 1 squared plus root 3 squared and then square rooted, which is going to be 2. And arg z is going to be, so, theta, or theta is going to be, if we look at it, it's 1 across root 3 up. So we don't need to find alpha, it is going to be just the theta in this case. So theta is arc tan root 3 over 1. And that is pi by 3. So we've got some information. We've got this and we've got this. Now what else does our question tell us? So it tells us that z squared over w is, the modulus of z squared over w is equal to the modulus of z. This implies that w equals z, doesn't it? Because z squared over z would equal z, so it implies that modulus of w equals the modulus of z. And this equals 2, as we've already found. So we don't need to worry about that. Now next, this real part here. So this implies that the real part is 0, so it must be imaginary. So if we think of our graph again, currently this is z, it's pi by 3, its distance is 2, and then W will be on the imaginary axis. So W1 or down this way, W2. So we've got to go either this way or this way. So if I call, change my pen back to black, arg W will call alpha. Then alpha must be going up to pi by 2 or down to minus pi by 2, isn't it? That's what, the argument of z squared over w must be plus or minus pi by 2. Okay, plus 90 or minus 90. So that's kind of all the information that I know, but this must be, so finding this going up to W1, we'd have pi by 2 minus pi by 3, which gives me pi by 6. So W1, well, I'll write it down the bottom here. W1 is 2e to the pi by 6i. Now I need to find going down this way. So this is, a pi by 2 plus a third. So alpha is pi by 2 plus pi by 3. And that is 5 pi by 6. But actually it's not adding them, sorry, because we're going in the negative direction. So it's minus pi by 3 minus pi by 2. So it's minus 5 pi by 6. So W2 is 2e to the minus 5 pi by 6i. And there we have it. So we're either adding pi by 6 to get to the top, or we're subtracting 5 pi by 6 to get to the bottom. Okay, and those are the two values for W, and that they both fall between pi and minus pi. So that one a little bit harder. Hopefully you managed to get it out. And again, just to remind you, if you found this video useful, hit the like button, subscribe if you're yet to, hit the join button if you're willing and able to help me out financially, and feel free to comment down below on videos that you'd like to see in the future. I mean, currently I'm producing the FP2 playlist, but for videos you might want to see in the future, anything you might want to ask in this video, I do try and reply to everyone, but I am busy and I do get a lot of comments, so I'm not able to reply to absolutely everyone, but I do make an effort to reply to most people. Anyway, see you in the next video, where we look at de Moivre's theorem. Anyway, that's coming soon, or might already be uploaded by the time you watch this.